Okay, Math 85, I'm back again. This is section 2.1, the first section in chapter 2. So we're going to be getting into some algebra. So the first thing I want to talk about, and maybe this will be a review for you, maybe not. Does anybody remember what a variable is? Anybody remember what a variable is? So in algebra, when we're talking about a variable is a letter that represents a number. Sometimes we know what the variable is, oftentimes we don't know what the variable is. And we can use any letter. So some examples. I know a lot of times people use X and Y, but I mean we can use A, B, D, W. We can use any letter we want to represent a number. And you're going to see lots of different letters used for variables as we go on. So it's just a letter that represents a number. And we're going to start using them in a minute. So next thing they talk about in 2.1 is a constant. Does anybody know or remember what a constant is? So a constant is a number whose value always stays the same. So any number, 5, let's say, 5 is a constant. 5 always stays 5. It's not going to turn into 7. It's not going to turn into 8. So it's just a number, any number that always stays the same. I mean, there's millions of them. So variable is a letter that represents a number. We can use any letter we want. A lot of times we use X and Y. Constant is something that stays constant. A number that always stays a number. Same number. 5 always stays 5. 12 always stays 12, etc. So, in algebra, we can use these variables and constants. We can put them together and write an expression. So an expression combines variables, constants, and operations. And by operations, I mean adding, subtracting, multiplying, dividing. So here's an example of an expression. 7 plus b. I've got the constant 7. This is my, get a different color. 7 is my constant because it's always going to stay 7. Plus is my operation. And b is my variable. I don't know what b is. I just know I'm adding 7 to b, the letter b. So they're going to ask you to translate this from math into words. And we learned a lot of different words we could use for addition. So there's a bunch of words. There's a bunch of ways we could say this. I'm just going to give you a couple. So we want to translate this. Sorry about that. We want to translate it from algebra into words. There was a bunch of words that we learned, I believe, in 1.2 for addition. So we could say 7 plus b. We could say the sum of 7 and b. Anybody know another example? We could say, let me just give you one more. 7 more than b. And I know there's more that we could use, but those are some that come to my mind. Let's say we had 12 divided by q. That's another expression because I've got constants, variables, and an operation. And I want to, sorry about that, translate from algebra to words. Okay, we learned a couple for division, I think 2 or 3. Anybody remember? 12 divided by q, this is my q. And does anybody remember another one? The main one, the quotient of 12 and q. So that's a couple examples of expressions. Again, an expression includes variables, an operation, a mathematical operation, and some constants, just all thrown together. Okay. What's the difference between an expression versus an equation? Well, we know what an expression is. Let me just give you an example of each of these. We've been doing examples of expressions. Let's say x minus y. There we've got two variables and an operation. An equation would be two expressions equaling each other. So if I said x minus y equals 15, this equals makes it an equation. So do you see the difference between the two? This is an expression, and this is an expression, and this is an expression. No equal sign. But whenever we throw in an equal sign between two expressions, it's now an equation. So does that make sense? So this is part 1 of 2.1. I have more to go, so I will continue in the next video, 2.1, part B.